Hi everyone, welcome back to this channel and I hope you guys are doing well. Today we are going to solve another LeetCode problem, valid parenthesis. Okay, this is one of the famous interview problem. In this problem we have a string s containing these characters. These are parentheses. Okay, so we need to check if the parenthesization is valid or not, and they have mentioned how to check validity. The first one is open bracket must be closed by the same type of brackets, okay, and the second, the bracket must be closed in the correct order, and the last one is every closed bracket has a corresponding opening bracket of the same type. Okay, if these conditions are fulfilled, then only our given string will be valid. So let's see some of the examples where parenthesization is valid and invalid. So in this example, the opening square bracket has its corresponding closing brackets, and the same for this curly bracket, it has their corresponding closing bracket. Okay, and the same goes for this one. So in this example, all the brackets have their corresponding open bracket of the same type and they are placed in correct order. So we can say that this is a valid parenthesization. Okay, similarly goes for this one. This open curly bracket has its corresponding closing curly brackets. Similarly for this open parenthesis has its corresponding closing parenthesis. Okay, and the same goes for this square brackets. Okay, now let's see some of the cases where our parenthesization is invalid. In this example, you can see that this square bracket, this opening square bracket has its corresponding closing square bracket, but this parenthesis does not have its corresponding closing parenthesis. Or in other way, we can say that this closing curly bracket does not have its corresponding opening curly bracket. Okay, so this is not a valid parenthesization, so we need to return false in this case. Similarly, in this example, this parenthesization does have its corresponding closing, and this opening square bracket also does have its corresponding closing bracket, but they are not correctly placed, so this is also not a valid parenthesization. Now the key observation here is that whenever we encounter any close bracket, for example here in this case, the last or latest opening bracket must be the corresponding closing bracket we are at. Okay, for example, if we are here, the last opening bracket is this one, so this is a match, therefore this is a valid. Similarly goes from here, when we encounter this close square bracket, the last opening bracket was this square bracket only, or we can say its corresponding opening bracket. We can check on the validity this way. So we can keep track of these opening brackets, and the last opening bracket should be at the top, meaning whenever we encounter a close parenthesization, so the last opening bracket should be the latest one. And you might have already guessed which data structure is suitable for this. This is nothing but stack. Okay, stack is a data structure, so that if we go from left to right and we keep track of these, all of these opening brackets, the last one will be at the top, and we need this data structure. So let's try it in this example and see. We iterate through the given string and check, is this an opening bracket? If it is, then push it on the stack. Move to the next character. It is also an open bracket, so we push it on the stack and move it to the next character. This one is also open bracket, so again we need to push it on the stack. Okay, and move it to the next character. Now this bracket is a closing bracket, so we need to check whether the last opening bracket was its corresponding opening brackets or not. So we need to check the top of this stack. It was indeed its corresponding opening bracket. So we need to pop out from the stack or remove it from the stack. Okay, and move it to the next character. This is again an opening bracket, so we push it on the stack and move it to the next character. Now we have close square bracket, so we need to check if the last open bracket was its corresponding opening bracket or not, and it was indeed its corresponding closing bracket, and therefore we need to pop out from the stack. And same goes for this one and this one, all are matching with the top of the stack. So finally our input string is exhausted and our stack is empty, so we can say that our input string is a valid parenthesization. Now let's draw for an invalid parenthesization. Let's simulate this example and see. In the beginning we have open bracket, so let's push it on the stack and move it to the next character. One is also opening bracket, so let's push it on the stack and move it to the next character. Now we have close bracket. Okay, and we need to check if the last opening bracket was its corresponding opening bracket or not. Now we can see that in the stack that the last one is this one, and this is not the corresponding opening bracket of this bracket. Okay, so we need to return it false. So our input string is not a valid parenthesization. Okay, so we need to return it false. Now it's time to code out and see it in action. We need a stack to keep track of those opening brackets, so let's call it st. And now let's loop over the string, given string, okay, and check if it is any of the input string, then push it on the stack. Okay, else. Now we have closing parenthesis, so we do not know which one, so we need to check. Okay, so we'll do that way. First of all, we need to check if the stack is empty or not. Stack must not be empty if we are accessing the element. Okay, and if the c is equal to this one is closing, then the top of the stack must be the corresponding opening. Okay, and if the c is equal to this closing bracket, I'll just write it quickly. So if our closing bracket is this one, then our last corresponding opening bracket must be this one. Similarly goes for other two brackets. Okay, in these cases we can safely pop out the latest corresponding opening bracket. Okay, otherwise if these are not true, then we'll just return false. Okay, at the end, when we are done with the iterating through that input string, just we need to check if the stack is empty or not. As you already have seen that in the valid cases the stack will be empty. See, in these valid cases the stack will be empty, and while in the invalid cases the stack won't be empty, there will be some characters in it. So we need to check at the end. So okay, let's run this code now. It seems our sample test cases are running fine, so let's submit it. Okay, it was indeed work. Now One more thing you can do with this code is, instead of typing all those equality and all, what we can do is we can store the corresponding opening brackets for every closing bracket. For example, this way, character to character. Okay, we'll be saying that for this closing bracket, the corresponding bracket will be this one. So we can store it in that way. I'm not going to do that. You can try it yourself, and instead of writing all those equality, what we can do, we can just check if this one is equal to, okay, we can easily check that. And now finally, one more trick I want to show you here. I usually use a lot in competitive programming, but I would not recommend you to use that in the interview problem. Okay, so let's head over to the ASCII table I have opened here. If you see here that this parenthesization, opening and closing, they have decimal value of 40 and 41. So if we use the difference decimal values of closing and opening, it will be 1 here, that is 41 minus 42. And for other, this one, opening square bracket has decimal value of 91, whereas the closing square bracket has 93. So their difference is 2. Similarly, somewhere we can find the curly bracket that has decimal values of 123 and 125 respectively. So in these two cases, the difference is 2, while in that case it is 1. So we can check that one. Instead of using this map and all, what we can do here is that since our closing is C here in this case, and our latest, either it is 1 or C minus the top one, it is 2. Okay, so in this way we can use it. So let's run this, and where we go. So let's submit it. I cannot assure you that in every language it will work, because in some programming languages like JavaScript, there is no character type but string. So in that way it will not work. And the reason behind it is working that in C++, behind the scenes the characters are stored as integers. Okay, now the time complexity of this code, since we are just only iterating over those string characters, length of the string, so our overall complexity will be order of n, where n is the length of the string. Okay, thank you for watching this video. I hope you liked it. So please do like this video and subscribe to this channel.